Hi friends, welcome to the Unit 1, Day 2 notes. We're on example 4, the domain and allowable values. Now we've talked about kind of interval notation, set notation. We need to talk about the domain of each expression. The domain is the possible values that you can have for whatever variable you're using. In this case, we're going to be looking at x. So there's a couple scenarios to look at. The first one is if we have a fraction. So if we have anything that we're dividing, we can't divide by 0. So we can't divide by 0. We cannot divide by 0. So if we can't divide by 0, that means we can't have a 0 in the denominator. So what we want to do is set x minus 2 not equal to 0 and then solve. If we add 2 on both sides, we get that x cannot equal 2. So because this is a singular number, if I write it in set notation, it's just the number 2. So set notation for this one is just the number 2. There's the set 2. We can't, then the next part is, if I wanted to write the graph. Oh, I'm sorry. We need to write the domain. So if x cannot equal 2, we're writing everything except 2. Excuse me. So if I'm writing it in set notation, I wrote what we couldn't have. So domain, we can write all the values except 2. So the way we do that, we're going to be starting with negative infinity. Then we're going to go to 2, non-inclusive. Union 2, non-inclusive, all the way to infinity. And that's everything except 2, because we just wrote the set, the number 2. This is the opposite of that. The next part is a graph. So that means we can't have the number 2, but we can literally have everything else. So we have open dot at 2, and then everything else is shaded or filled in. And then interval notation. So for interval notation, interval notation. I missed set notation. The set of x's, so set. Let me put it down here. So I have the set of x's such that x is not equal to 2. There we go. All right, so I'm going to write these off to the side just because I put them in a different order. Set, graph, and then interval. There we go. Continuing this idea with number 10, we can't have a negative number underneath the radical. So we set whatever is underneath the radical greater than or equal to 0 and then solve. So if I subtract 4 from both sides, I get x is greater than or equal to negative 4. I'm going to continue this pattern here because I already continued it. So interval, my interval notation, I start at negative 4 and I go to infinity, so that. And then for my graph, what I have, so I'm going to have a number line. So if I'm making my number line, and then from here, what I have is negative 4. Here's 0, so I can include negative 4. I'm going to shade it in, and then filling it into the right. And then the next part, for set notation, I have the set of x's such that x is greater than or equal to negative 4. There's that. For 11, 11 is a little bit tricky. We can square any number. There's no issue with squaring. We can square whatever number we want. That's not a problem. So what I want to do for 11 is I want to go through and just say, well, I can allow any number I want. I can pick whatever number I want. So for this, our interval notation of this would be from negative infinity to infinity. We allow any number. Our graph for this is everything. We made that earlier. And then for set notation, we have the set of x's such that x is an element of the real numbers. There we go. There's example 4. I will see you in the next video.